Don't forget to like and subscribe.
It's Jim Keller, everybody. It's George Cosmo, everybody.
I still get a laugh out of that intro video.
And you'll say that every time we do a tech.
I know. I don't think it will ever get old.
It's so yeah, George and I are here at
Supercomputing 2025
in St. Louis in the state of Missouri.
Yep.
And it suddenly got very cold yesterday. We're now going down to single-digit degrees Celsius.
Yeah, I was going to say it's about 40 degrees Fahrenheit for the American viewers.
But George and I have just spent a few days together in San Diego with our good friends Qualcomm. We can't tell you about any of that just yet.
Nope.
But then we both flew to St. Louis to this annual trek to the home of high-performance computing as it used to be.
Yes.
As it used to be. And it really stings everyone who attends, because now this is not the bastion of the highest performance compute, because that's now all AI data centers.
Yep.
And none of them are here.
Nope.
So today is officially day one of the show. We're actually missing the keynote.
Yes.
To do this. And that's because George has decided to book about 15 million meetings this week, and I booked one.
Yes. Yeah. So usually he's the one that has all the meetings, and I have just to explore the floor. This year it's swapped. I have all the meetings, and he gets to explore the floor.
Except at this time, I'm doing it out of experience, as in I didn't want to really book anything. I'll just turn up to booths and say, "Hey, you want to chat?"
Yeah.
I've got an interview recording tomorrow, which should be good. I still need to actually book this room to do that in. But yeah, technically today is when it all officially starts, but we've already had web tutorials and workshops for the last 2 days.
And the opening of the floor was yesterday at 7. So we have been on the floor a little bit.
Yeah, they open it on the Monday for 2 hours. Normally it's 5 to 7. This year it's 7 to 9.
Yeah, I would have liked it to have been 5 to 9. That would have been nice.
Yeah, but as it's the opening gala, they provide drinks and food, and they don't want to keep doing drinks and food for 4 hours. But it does give a chance to, put some miles on the moccasins, so to speak. Though I was walking around with Andy from Chips and Cheese yesterday, and we just kept getting stopped every 15 meters.
Yeah, that happened to me 3 times yesterday, and I'm surprised there was only 3.
Don't get ahead of yourself. It's still amazingly surreal when people go,
"Yeah,
I want your stuff."
Actually, what's funny is somebody who is here, Will.
Yeah.
He was the first person to ever stop me.
Right.
I know you.
Yes.
So
we bumped into Will yesterday. He was chatting with some old colleagues, but most people don't show off the wares in those 2 hours. They just show off presence. And when the keynote is done, we have to finish by 11 a.m. Central because George has another meeting. But we did see some inklings of some chips and some demos on the show floor already.
So stuff to feed him with.
I've already started chomping on HBM4.
How tasty was it?
It was pretty good. And I think we got a pretty important contact from that discussion. Somebody who clearly wants to get involved. Technical marketing with a memory vendor.
Interesting.
Memory vendor that's not American.
Well, that's still 2 of them.
Yes, exactly. It's going to be fun. I walked by the Light Matter booth because they're promising a demo. Apparently the demo's today. But we did take photos about their line rate and bit error rate already. I'll reserve judgment until I get the explanation. But I would like to. So we walked by just as the show floor was closing, so nobody was at the booth, and the rack that they had was still running, but locked. So we could see the panel through the little hexagonal mesh, and I took pictures. And it had some of these stats on, but I want to be able to pull the rack unit out. and see exactly what's going on, because they promised me a demo. I will see a demo. But yeah, no, we bumped into, we saw the Formula One car at the Microsoft booth.
Oh yeah, yep.
And they have the MI300C, the CPU, on display.
Still want to get my hands on that.
Well, you can put your hand an inch away from it. It's covered by Perspex.
Yes.
And it's seemingly gold plated.
Oh, interesting.
Compared to the regular one, which is silver. Well, it's you know how they're doing thermal interface material now.
Yes.
It's all tin, indium, alloys, and as a result, you have to polish and plate. And so we've seen it on other AMD CPUs where it's polished and plated in a gold color.
Yeah.
For preparation, and that's usually the ones that they pass around for showing. For showing, yeah. So I bumped into an old friend, former Intel employee, who's looking to grow optics on your chips. Interesting. Using ALD and CVD.
I'm not familiar with those terms.
Atomic layer deposition.
Oh, okay.
So like leading edge fab tooling.
Yep.
We had a good chat for 15 or so minutes and early stage startup stuff. But sounds really cool.
Yeah, like growing optics on a chip would be very interesting to see just as it happens.
Yeah.
Yeah.
And how expensive it will be.
Yes.
there is that.
Which I suspect the answer to that is yes.
If you have to ask, you can't afford it, sort of thing. Already looped around some friends, our friends at IR Labs. They've got a booth. Annoyingly, it's all the way at the back.
Yes.
So Supercomputing, for those who don't know, it's the big high-performance computing event of the year, half academic, half industry. So there's lots of tutorials, lots of presentations. They're all going on upstairs. And then downstairs, it's the a traditional trade show floor, but also a lot of the academic universities are there. And they're showing off what they're doing. They also use it as kind of like a PhD postdoc academic hiring.
Well, did you see the location of the posters?
Are they upstairs?
Yes. So if you basically go up, if you start going towards the exhibit hall from here, and there's an escalator.
Yeah.
Basically, just go up the escalator, go straight into your right.
Yeah. The academic posters are usually worth spending a good couple of hours running around, because you'll see just weird things out of your eye. Like the last time I saw Xeon Phi, Knight's Mill.
Yes.
Was on a research paper there. And then it took me 6 years to actually buy one from eBay, because that was I wanted the highest SKU, and it took me ages to find the highest SKU. Also, I bumped into on the show floor Emma Iwao from Google. She held the Pi World record twice.
Oh, did she?
Former Pi World record holder. Bumped into her on the show floor. I haven't seen her in a year and a half, back when we were doing the hand calculation of pi with Matt Parker. That was a really fun, and I've got a video on it. But it was best part of 300 people, and in a week we calculated to something like the 170th digit of pi.
But that's actually
by
really
hand.
By hand.
By hand. No electronics.
No, by hand.
The start of the week, we were literally writing out times tables.
Yep.
And I mean, this is like the 593,123 times tables.
Yes.
Because digits. But it's also and it turns out, as you do that, you also have to implement checks, and you have to have quorum on your calculations. Kind of feels like a processor.
It's almost as if computers used to be people.
Oh yeah. There's a film about that.
Yes.
It won an Oscar.
Yes, it's a great film.
It's a great film. So we're technically at the start of the show. A lot of companies have already done their announcements, because they get their announcements out the door before the doors open. So a lot of them went live this morning. Is it Cornelis?
Cornelis went live with CN6000 SuperNIC.
So that's the networking company who took over OmniPath from Intel. And then also yesterday we had our media briefing session, where we get to today's first topic, Top 500, which is the list that they update twice a year about the highest performing supercomputers in the world,
that submit.
Brackets that submit results to the leaderboard. So one of the big things this year we should start with is no new Chinese systems.
Nope. Which doesn't really shock anyone, but
it's we know that China has really big supercomputers, but because of a mixture of tariffs and limitations and compute, they have big systems. I mean, the last
I like big systems and I cannot lie.
it's when we were trying to go past the exaflop barrier. Technically, we believe China to have had the first one in the Sunway system.
Yeah.
But they never submitted, though apparently Limpak was run. And people in the know saw the result, but it was never formally submitted. So top 500, the US didn't have much new showing this year in the top 10, because at the top of the list, supercomputers like Frontier and El Capitan, they were last year's systems, and no new systems came in. Though we did have recent announcements, we covered them on the Poutine last time. AMD and NVIDIA have lots of contracts to build lots of government supercomputers.
Yeah, let's talk about let's start with number 4 on the supercomputer list. So of the top 5 on the top 500, there was no change except for the number 4 system, also known as Jupiter. The booster module of that system, which is the primary compute module for Jupiter, has officially hit the 1 exaflop barrier. It is exactly 1 exaflop.
And no more.
1.000 on the list.
It has 3 zeros. I thought it only had 2.
No, it's 3 zeros.
Okay.
At least that was the number on the
and that's measured by benchmark, not theoretical peak.
That's the R max, which is the measured number in Limpak. The R peak, I believe, is like 1.2-ish.
Okay, so that's actually pretty efficient as well.
Yeah, it's like 1.2, 1.3.
Yeah.
Like that.
Yeah. So now we have 4 exascale systems. That's exaflop based on FP64.
Yes.
Because there's one of the discussions in the media briefing where they walked us through the list was about whether mixed precision is the right thing to do because of AI. We have lower precision math now, and whether scientific compute can live with reduced precision, because in some instances you can't.
Yeah.
Nuclear, finite element, but in some aspects of those you don't need.
No. You don't need it, but like high energy particle physics, like they thrive on FP64. And I know we were talking about what's known as Ozaki, which is FP64 emulation using, I believe, int 8.
Yep.
I was talking with our good friend Felix.
Yep.
And while Ozaki does have its uses, the numerics behind it are kind of mystery meat.
You don't like it?
No, I don't. It means that repeatability can be questionable.
You're talking about repeatability between systems. On the same system, it will be the same.
Well, not necessarily.
It's not using a random number generator.
No, but it could, in theory, it could be impacted by the difference in.
You mean like the summation scheme?
Yeah, like if you're running, say, 8,000 nodes instead of 4,000 nodes.
Upscaling.
In theory, that could change some things.
Yeah. But if you just press run, result, you'll get the same result.
Yes, you should. You should. But if you don't, that's probably where software thing.
So the funny thing is, because this discussion came up, Jack Dongara, who's been involved in the top 500 for decades and also has so many books.
He was I think he was one of the co-authors on the first one.
Yeah, and I have a number of his books about high performance computing. And he was asked, does it matter? And he said, if I get the right result, it doesn't. So he sounds pretty flexible when it comes to mixed precision, but that's why we have the top 500 mixed precision.
Yeah, MPX or MXP.
Yeah, and if you go down from 64-bit to 32, 16, 8, in some systems you can get what they call a 24 times speed up, which is just a 24 times in how many calculations you do.
Mm-hmm.
Not in the time to get a result.
Yes.
And that is because intrinsically, historically, the number of calculations you do should be directly tied to how quickly you get the result. But that's only comparing if you're doing the same precision comparison.
But also that assumes that you're compute bound. And a lot of HPC is not compute bound. That was another big topic was NVIDIA's Blackwell, specifically the B200, doesn't actually increase the FP64 very much, but the bandwidth nearly doubled in terms of the HBM bandwidth.
Yeah.
So, and they saw speed up with those systems, even though the FP64 did not bump up as much as some people would have expected.
Yeah, it's 64-bit gen on gen hasn't been increasing. We've got somebody trying to get in. Do you want to see what that is? Yeah, and if your 64-bit performance doesn't increase, but your memory bandwidth does, then you get better performance in like HPCG, the conjugate gradient benchmark.
Yes,
that's a fun benchmark because you get the LinPack Rmax, which is, even though it's called Rmax, it's the maximum performance, not the peak performance,
which is RP.
Which I have to keep
confusing.
And HPCG as a real-world test is given as a fraction of Rmax, and most systems are under 1, except for Fugaku.
Yes, which is 3.
And that's an A64FX ARM-based processor. That's still number 7 in the top 500. So that's 3%. But yeah, and then now we're seeing some Blackwell systems get to 1.5%, 2%.
Yep. Actually, what was impressive, so they haven't announced the Gordon Bell Prize yet. That's a prize that's given out every supercomputing for what is
the highest impact research. There's 6 finalists. Cerebras has been part of the last 2 or 3.
Yes, but this one of the finalists is actually the Frontier supercomputer, which used to be the #1 supercomputer in terms of the top 500, has been dethroned by El Capitan, but is still number 2. They manage on a code base known as HACK, or the hybrid / hardware accelerated cosmological code. That code base, bit of a mouthful. HACK, or HACC. They managed to get over 500 petaflops of performance. Which is actually really impressive. So the R max number at HPL for Frontier is approximately 1.35. So they were managing to get about 40% of the system in that code base, which is honestly...
The thing is with these supercomputers, I've asked before, how often do you use the full computer for a run? And they said very rare. They say very rarely.
Yeah.
Right. Most code needs less than 10% of the system. But there are situations where you need the full system.
Yeah, they ran it on nearly 9,000 of Frontier's 9,400 nodes.
Because the more hardware you put in, you also have to account for things like node failures and link drops. And this is why having a system of multi-gigawatts, which is what some of the AI systems want to be, is a problem just in hardware maintenance. You have to be able to have checkpoints and failover. And so you don't want to waste a week's worth of power to lose your calculation. Especially when, we're talking megawatts.
And actually, sort of on that topic, the way that especially the American systems are set up with in sort of what's known as a dragonfly topology for its networking, they're really more a bunch of mini supercomputers that can talk to each other than one big system.
Well, it's like Huawei's UB mesh as well.
Yeah.
Yeah, well, one of the things in system design is, what's your blast radius? Meaning, if a node goes down, how many other nodes does it take out? And you want that to be as small as possible, but in order for it to be as small as possible, you need it to be as least connected as possible.
Yeah. So, for example,
or as most connected as possible.
No, as least connected as possible.
Yeah, but that reduces your bandwidth node to node.
So, for example, if a Frontier node goes down or an El Capitan node goes down, you lose 4 GPUs.
Yeah.
You could argue 8, but MI250X aside, you lose 4 packages. On something like an NVL72, if you lose one of the nodes, you lose the entire NVL.
Do you?
Yes. You end up basically having to hold the entire system.
Because I know with one of the TPU pods,
Mm-hmm.
the V6Ps, I think, you lose a chip, you actually lose something like 512 chips. The blast radius is massive.
Yeah.
But that's because it's a hyper-connected torus, 3D torus or whatever, a 2x2x2x2 design, that sort of thing.
Whereas HPC is a lot more reticent to, like they don't like large blast radiuses, whereas AI is perfectly fine with them. So that's why we're seeing sort of differentiation in system design.
Can you open that and see what's going on?
There is a sign.
There's somebody out there, Andy. Yeah. Okay. It's technically we're in this room early because the keynote's going on and they want everybody to go to the keynote, but because George is busy. The one I did have a small gripe with the top 500 announcement, and it's they can't seem to decide whether Grace Hopper, as the super chip where you have a Grace and a Hopper, is a CPU or an accelerator.
Well, the CPU is Grace, the accelerator is Hopper.
Yeah, and they keep calling
the accelerator Grace.
Yeah,
and Hopper is just off to the side again.
All the there is somebody there.
Anyway,
yeah.
Hopefully.
Or just prop the door open slightly so if they come in, they come in.
Yeah.
And actually talk.
Yeah.
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 So.
Anyway, so speaking of.
Of the Green500 list, all the new systems are GPU based.
Yep. Interesting enough, I don't remember there being a Blackwell on that Green500. It's all Hopper.
Yeah, and that's because it's Grace Hopper.
Yes.
Yeah. One of the things was they felt like there wasn't that many new Blackwell systems.
There was 8 new systems.
And given how much Blackwell hardware has been sold, because it's all gone to AI, and AI systems, while they could submit, like Eagle.
Yep, that's the number 5.
That's the number 5 supercomputer. That's one of OpenAI's big systems. That was built by Microsoft.
Yes.
For OpenAI, and they could submit, but they don't. Same with China. But if you're doing AI, why would you spend a couple of days trying to get your full system to run Linpack? Well, because it can be an effort.
Well, it's also a good systems test, right?
Yeah, and then you find out that half your stuff needs repairing. So there was this. They felt there was a disconnect with not enough Blackwell systems. The only new systems on the list that had accelerators were either AMD GPU or NVIDIA GPU. So no new Intel accelerator systems this time around, and no new third party, right? So at some point we're going to get a PC4 on the list.
Yeah. Hopefully.
They did say that they've slowed down. So it's normally the way that they measure the performance of the top 500 is where the average flop rate is, the number one flop rate, and then the sum flop rate,
Mhm.
but also the one that's also 500th.
Mhm.
And they're finding that the system that's 500th isn't increasing as fast as it used to historically. And that's kind of because they say it's because it's an asymptote of core count, as in core counts aren't increasing as fast as they used to.
Well, yes, but also define a core.
That's the question.
Yeah.
Right? Because we're at a point now where, an NVIDIA GPU is counted as 22,000 cores.
Or
12,000 or whatever the number is.
Is a CUDA core a core, or is SM the core? Exactly. Like a CPU core is fairly clean cut.
Well, then you've got threads, but then you've also got ALUs.
Yeah. Well,
and then how wide is your vector
CUDA
engine?
core is an ALU effectively.
Yeah, and
right.
Well, no, because the idea is that if you have multiple ALUs in a core, you only have one or two threads and they context switch. In an SM, you have 64 ALUs, but you're issuing 64 threads.
Yes. So to me, the question is where is the instruction pointer from?
Yeah.
Right. And I think that is what we would class as a core.
Yeah.
So like an SM or a WGP or a CU is a core for a GPU.
Yeah.
Right. That's at least for me.
It does get it. The thing is, the top 500 and the other lists, they're tracking metrics that were relevant when the list started. Unfortunately, as some of these numbers have increased, I mean, you could argue is flops the right number, and the fact that they're calling non-double precision operations flops still, that annoys the hell out of me. We have the meme from our good friend Felix. What type of flops? But yeah, it's overall, it was a fairly sedate update to the list. Oh no, that's right. All Blackwell systems that were on the list, none of them were in the US. Yes, there were. Well, none of them that submitted were in the U.S., but there likely are more Blackwells in the U.S. than anywhere else. Yeah. So we saw systems from Japan, Poland, Taiwan, Israel had a couple, and then, but also on the top list wasn't ExxonMobil as well. They've got a system in the top 10 now, or is that the green top 10? One of them. It may be the green top 10. Yeah. ExxonMobil in the green top 10. There's some controversy there. There's a story there. Yeah. If ever there was. Yeah. So this list is updated twice a year. Once at Supercomputing and then at International Supercomputing. Though I'm not sure how long that event's going to be around, given it's such low attendance this year. So by contrast, they're expecting at least 17,000 at Supercomputing this year. Less than 3.5, maybe as low as 3,200. That's a drop that's been a continuous drop. Yeah. International Supercomputing is held in Munich. No, Hamburg. Yeah. So whether it's indicative of just the fact that Europe's not a great place to do tech, high performance tech, embedded in automotive, sure. And even though some of the top systems. So speaking of, there was a press release that went out today. So sort of looking towards the future, as we talked about, the likely to be fastest supercomputer at some point, Discovery was announced. That is the successor to Frontier. We covered this last week. We covered, a couple weeks ago. Yep, last routine. Yep. And we just got an announcement that Evident, which is a French company, is building Europe's second exascale system, which is based on Venice and MI430. Where are they building that? In France. I don't think they said where yet. Let me see if I can pull up the. Are you sure it get built? Who knows? This is not the right press release. Yeah. I know what you mean. It's Yeah, and yeah, so we've already got a lot of companies talking about MI 430 for next year. Whether that's next year June or next year November.
Yeah,
it's probably November.
But well, they didn't give a timeline for the build. But they did give us the number of racks. They said 94 racks, and I went and I asked,
like Helios racks, basically.
Well, no, like 94 racks, and I asked Evident how many racks in the system is the XH3500, and they said up to 32 GPU racks or GPU nodes per rack.
Okay.
Assuming the same one Venice, 4 MI3 430s.
You can do the math.
In order to hit an exascale, you're at about 100, just over 100 teraflops of FP64 per MI 430.
Okay. Have you got an article on this yet?
No.
Just do an article going through the math so everybody follows. It's a very simple piece. You only have to do 200 words. Like, we found this data, and let's just do the back of napkin math.
Yep.
And then you can also perhaps work out power.
Yeah.
And then efficiency.
Well, efficiency is harder, but power fairly.
Well, I mean, flops for what?
Oh, yeah.
So so for those of you who aren't following, AMD has announced the MI 400 series to be coming next year, but it sounds like there's going to be a variant called MI 430X, which is going to be specifically for FP64. And then the MI 450 is going to be more for AI workloads.
Yes.
And this is you could call it to counteract the fact that NVIDIA's not putting out FP64 focused hardware anymore, or whether they even want the market at all. However, Jensen was on the show floor last night.
Yes, for like an hour or so.
We overheard him from the Microsoft booth. Apparently, Jensen mugs were being handed out.
Yes, at the NVIDIA booth with the Spark drink. Literally, drink called the Spark.
Oh, so the video doesn't work on your drink, or immediate. It's half MediaTek. It's half orange, half green. Yeah, it means you can't see.
Yeah.
Actually, that's one thing, because I spoke with our good friends Patrick Kennedy from Serve the Home and Wendell Wilson from Level 1 Techs, and it sounds like they're able to now get plenty of Spark samples from different vendors. So not only the NVIDIA one, which is like the small box,
yes,
but also MSI, Asus, I think, as well.
MSI, Asus, Dell, Gigabyte, Lenovo, HP, a whole list of the standard sort of OEMs that you would.
So even though this system has had a delay, given the fact that reviewers are very quickly, or people who are testing are very quickly getting their hands on them, do you think it will ramp quicker than Strixhaler?
So what's interesting is press usually gets samples in one of two cases. Either the company wants to showcase something, or they want people to talk about a product.
Yeah, mindshare.
What's interesting is there were review samples sent out for Strixhaler. But what's really interesting is that Spark, seemingly more samples were sent out.
It's part of the reason why so few Strixhaler came out is because AMD underestimated the interest and only partnered with Asus and HP. And Asus went, let's build a new mobile chassis for this, because you had the Flow Z13, and HP said, let's just repurpose chassis for other products.
Well, actually, this is a new chassis.
Well, it is now.
Yes.
The one that they were showing off initially wasn't. It was. It was. Yeah. It had already been reused.
Oh, was it?
Yeah. And that's because it's a case of the OEM going, well, AMD's told us that they'll sell this amount, so how much effort should we put into actually rebuilding this?
Yeah.
And it comes back to, I remember discussions I was having with AMD at the time, whether it should be promoted as a gaming chip or a workstation chip, or
I think everybody at the once the AI boom hit, I think all the analysts basically told AMD, yeah, you're severely underestimating demand.
Yeah, we did.
But
if you give a call up to your silicon providers and say, I need 1 million units, they're going to say, well, there's a 6-month wait.
Yeah.
Right. There is a lag on this. And even if you think, there may be 1 or 2 million Strix Halos sold over the lifetime, how many Sparks?
I've heard that I've heard numbers for that for this year, and it's higher than I was expecting.
So I spoke to a tier 2 OEM, and they said they're in the process of designing their Strix Halo system, but they're not expecting to get chips in until the start of Q2. That's their allocation window. And so they're debating whether there will still be interest for that product around that time. And they obviously have to gauge how many to bring in.
Here's the thing, as long as people are still doing some level of AI with it, 128 gigs of RAM sort of is just like...
Oh, it has to be the top spec chip.
Yes. Yeah. For gaming, 32 or 64, it's fine. But if you're doing anything AI, 128, 128, 128.
Because you want to run that GPT OSS 120.
You can run that on the 64 gig model. Just
don't ask for accuracy.
Well, it's an MX FP4 model.
So.
And actually, so you bring that up. That's one of the reasons why AMD didn't think Strix Halo would do very well. Is because it doesn't have those lower data types.
Yeah.
But 128 gigs of RAM, kind of just.
Yeah.
But my point was more that of the companies that did design custom chassis for it, they're not begging for review samples, which to me sounds like, or they're not begging for people to review it, which makes me think that they're selling well.
I have seen recently that some companies' review programs have been slashed, and that's just due to internal politics and people. This industry goes in cycles sometimes, and it means new people come on board and they don't know how many samples they have, and or I know with some because now I deal with analyst relations for most companies, they don't get many, if any, samples to send analysts. So I had to buy my framework. I'm not sure what will happen about Spark. I may be getting in a battle matrix.
That would be fun.
So, but whenever that's ready, which may be this year, maybe next year, we'll see. So, let me just get my phone for a sec. Everything was going on the show floor yesterday. Before we wrap up supercomputing, I do want to go through some of the stuff that I saw. Cisco has ASIC silicon display.
Silicon One.
Silicon One, with lots of chiplets.
Were they talking about?
We didn't speak to anyone.
No. What did they show off? Their next gen, or was it just the current gen? Was it 200 or 300?
They had G200, P200.
Okay.
And then the set of 100s.
Okay.
But some of the silicon was 2024 week 52. So, about the right time between, tape out and bring up. We went by the NEC booth.
So, fun fact, there is going to be a new vector engine.
Yes.
Apparently, it is RISC-V vector-based.
No. So it's a RISC-V core with the vector engine attached.
So is it still using the vector engine ISA?
Yes.
Oh, thank God. Okay, good.
The one key thing we did find out, and it's in the slides that flash up. This is a 2029 product. So it's NEC vector engine came out 5 years ago, 6 years ago,
something. I want to say it was like 2017, honestly.
I have a photograph of every slide that they showed in the video. And they had the Vector Engine 10, 20, 30, all roughly built on the same architecture. This is from NEC, that company.
Yes.
They never really made a big song and dance about it ever.
So the NEC, the Vector Engine, also known as SX Aurora, was announced in a press release in October 2017 and started selling it in February 2018.
And Vector 10, 20, 30, by and large, just has the same architecture. It's just powered with more memory or the chip's bigger. But the question is, when's the next architecture coming? Are they going to call it something else or what have you? And this is a collaboration with OpenChip. So they're using OpenChip's RISC-V core.
Okay.
Their Vector Engine ISTA for the Vector Engine to put it together, and it sounds like it's for a custom chip for OpenChip, not a custom chip for NEC.
Interesting.
We've got friends who have played with NEC.
Yes.
And for certain workloads, it's really good. It's just that the software stack is a pile, a steaming pile, because it's not designed for consumer use. It's designed for, it's...
Actually, I have a meeting booked with NEC tomorrow morning.
This is a picture of what it looks like.
Oh, so 8 compute chiplets, 2 I/O chiplets, and then 8 memory?
8 HBMs,
Yeah.
So it's 2029. That'll probably be peak 2 nanometer volume.
Yeah.
And HBM4 will be readily available.
Yep.
HBM5 would be 2 leading. I think 1.4 nanometer might be 2 leading.
Could be 1.6.
Yeah.
Although who it could be? Could be Rapidus.
No, I don't think Rapidus would be in line for that. I did have a table. Maybe I didn't take. Oh yeah. So it's the RISC-V OpenChip integrated architecture.
Roya?
Royer.
Royer.
Yeah. And the vector, the diagram that they showed, unfortunately, we'll put articles up online. That kind of looks like Qualcomm's vector engine.
Yes, like that diagram kind of looks very suspiciously similar.
But no, they're leveraging all of NEC's compilers and stuff.
Okay.
And traces and vectorization and directives and extensions. It's an LLVM RISC-V backend.
Yep.
So, I got a bunch of pictures from there. Didn't speak to anybody because when you're doing a gala and everybody's having a drink, you never know exactly
who you're going to
get. Broadcom had Tomahawk 6.
Ooh.
On display there, but the 102.4 terabit version, not the 200 yet, but it is 200 gig per lane CPO PAM4. It's not true CPO. It's on board optics, but my perennial battle with people wanting me to label co-packaged optics or on-board optics as co-packaged optics. If you don't know the difference, I've got a couple of great videos that go through line by line what the generation is, and then eventually we get to growing optics that I talked about earlier. But we've only got like half an hour left, so let's get into the second big topic. And this is one that you've been shouting at me for a while, and it's funnily enough, I know a bit more about this. So do you want to cut the topic?
Ironically enough, 2 days ago, Patrick Kennedy from Server the Home, our good friend, broke the news that Intel has decided to kill the 8-channel Diamond Rapids series of CPUs. Now, Diamond Rapids is likely what's going to be known as Xeon 7. So this is their next generation chip. And the 8-channel platform is sort of the more mainstream platform. So
it's P-cores.
Yes. So there's with Granite Rapids, there's the 6700 and 6500 piece SKUs. This would be sort of the 7700P and 7500P SKUs. That lineup of SKUs and that sort of product stack seemingly was canned. So there will no longer be a mainstream Xeon or at least for Diamond Rapids. I know you have a little bit more.
Right. So to clarify how it works in my mind, right?
Mm-hmm.
We've got Xeon 5, Xeon 6. Xeon 6 is P and E.
Mm-hmm.
Inside P you have two families.
Mm-hmm.
That's the low memory and high memory. Then going on to Xeon 7,
Mm-hmm.
you're going to have E and then P, but then P has low memory and high memory.
Mm-hmm.
Clearwater Forest is technically called Xeon 6 Plus, not 7, just to make it annoying. But under the P, so that's the Diamond Rapids family. Out of the low memory and high memory, they're getting rid of the low memory part. And this is because officially the next generation after that, Xeon 8, so to speak, is called Coral Rapids. And this was Coral Rapids is expected to be sort of late 27, early 28.
I thought it was Ruby Rapids.
Coral.
Oh, maybe Ruby is the successor to Coral.
But the thing is, given what the CEO has said, one of the things he's been keen to do is bring back hyperthreading to P-cores on server, especially. And we knew that Diamond Rapids wasn't going to have that.
Yeah, which is odd because I remember when they first announced at ITT Taipei, they announced that Lion Cove for consumer wasn't going to have SMT, but that they could add it back for server.
No, they could, but they didn't.
Yes, which honestly shocked me. I was expecting it to.
There are narratives for and against hyperthreading and simultaneous multi-threading. But Diamond Rapids as a design so far doesn't have that. And because LitBoo wants to return to competitiveness, they felt that Diamond Rapids would be competitive, but just not competitive enough. Because when Diamond Rapids come out, you're right in the middle of AMD Zen 6 epics, the Venice epics. And the idea would be that Coral would compete against the Zen 7. What they've done is that during the design of Coral, they've found an opportunity to speed up the design procedure for Coral. They call it pulling in a design. So the idea is that rather than put out a mainstream okay-ish part, which is kind of already served by Granite Rapids today.
Yes.
Let's go and accelerate the products that will actually be truly competitive. But they haven't done this just because, right? They have actually identified a way to bring it to market quicker. And they've taken the team from the 8-channel, from the low memory Diamond, and put them into assisting the Coral team. So normally when you go through chip design, 7 years out, you're pathfinding, you're speculating, you're moonshots about what's happening. 5 years from CPU design, you're kind of narrowing it down to thinking exactly what cache structures, what process nodes. You
start basically
zooming in.
Yeah, zooming into design. And about 3.5 to 4 years in, you basically...
you start putting the Lego blocks together.
Yeah, you start solidifying the design about 3 years in. You fully solidify it, and then
you still also need to integrate with the foundry about the PDKs, and that's usually solidified 2.5 years before design. And we're well beyond that for Coral now.
Yes.
But the idea is that instead of with Diamond being what was meant to be a 26 part and Coral meant to be a 28 part. The idea is that can they bring Coral in to a mid 27 or maybe even an early 27 part? At least the Coral mainstream.
Yeah,
Coral high end might still be later.
So based on what I think I've heard murmurs about, I suspect it's actually more 20 Diamond Rapids in whatever form it shape and form it comes out. Likely the 16 channel part, or what would be known as AP. So the mainstream part is usually SP. The high performance part is AP. So if you hear me say AP, that's what I'm referring to. The AP part is probably going to be like an H127 part.
What do you mean by H127?
Like announcement at, potentially at like CES.
First half of 27.
Yes.
Okay.
Yeah.
Yeah. It's the whole point is, why bother putting out a part that you know won't be the best performing and continually being behind rather than trying to catch up, right? So now there are implications, things like, well, if you don't put out a part, you won't get any revenue. And it does mean that your competitor does get to spend more time ahead. But we always knew that once consumer and enterprise started going off cadence, because they used to be launched together every 18 months or so. And then they started delaying the enterprise a little bit because of 10 nanometer, a little bit because of the rebranding done by that idiot. But it's because of this off kilter. We always expected that at some point server would skip a consumer generation of core, right? And this is just them turning around and saying, we've got an opportunity. Now, it could be that, we're expecting that the compute dies are going to be based on Intel, right? Intel Foundry. This could be, they're bringing it in because this could act as the pipe cleaner for whatever process is coming through, for a 14.
Or potentially what they're doing, and this is not unheard of, but let's say, for example, on MI 350, AMD did not change most of the cache structures because it was already what they called overbuilt for AI. Maybe they overbuilt DMR's Mashin sort of Uncore, and they're just sort of reusing that and putting the new core in.
It's weird because I worked with Intel on this, and it's important to realize that because an opportunity was identified, this decision was made. It wasn't this decision was made and this is the result.
Yes.
Right. It's because it was quite telling the way that you initially explained it is they've cancelled this. And in my mind, it's no, they saw an opportunity and therefore they brought it in and things have changed. And that's just my PR brain working. and this is why I get paid for consultancy. But yeah, it's a lot of people are earmarking this as more of a downfall of Intel. No, this is just Intel trying to catch up. And it's also, if you look at the recent financials, it is the client computing group that's bringing home the money. Funny thing, one of the first banners I saw at Supercomputing was for Gaudi 3.
The one just before
the one in the big hallway that says Dell Gaudi.
Well, what's interesting is that there's 4 Gaudis in that. I didn't think that they did 4. I thought it was only up to 2, but I rechecked the slides and it can go up to 4.
It's we're going to have to go by the Dell booth. Well, you already had your meeting with
Dell. I had my meeting with Bubba from Dell.
So, it's. Is there anything else we want to say to this? So it's one thing to note with. So this is the low memory version, but it's actually Intel's high volume.
Yes.
So when you make a decision like this because of an opportunity of pull-in, it does affect volume to the tune of millions of wafers.
Yes.
So you do it's not done on a whim.
No.
Right? This is a multi-billion-dollar decision.
But also, let me ask you a question. For all the folks that were looking at Diamond Rapids as like a replacement for, let's say, Sapphire Rapids or Emerald Rapids, right? Because most people don't.
At this point, I really just do prefer saying Xeon 3, Xeon 4, Xeon 5. Because most people don't upgrade every single cycle. Most people, not everyone, but most people don't, especially not in enterprise. Do you think that this may harm trust with Intel's partners in that space? Let me tell you the story about why Intel, on the consumer side, only kept chipsets around for 2 generations, sockets around for 2 generations. It's because if they didn't, the motherboard manufacturers would go bust. Right? And I know so many people complained. So Sandy and Ivy was 1 socket. Then we had Haswell and Broadwell, and then going forward, it was always 1 2 1 2 1 2. Is that even though they were all like 11.5x in terms of pin count, or they're all 1150, 0 1 5. And some people got CPUs working in sockets and boards that they shouldn't. And they're like, well, this is all compatible. Why didn't Intel make it universally compatible? It's because if they didn't, Gigabyte, MSI, ASRock, and Asus, who all at the time were 95% motherboard manufacturers, if they didn't have a new product every year that increased the cycle of sales, they wouldn't exist today. Now they're all diversified, right? MSI is massive in laptops. Gigabyte has a massive server division and laptop division. ASRock is still ASRock, and Asus is a big conglomerate anyway. So that perhaps doesn't need to happen anymore, but it was done to keep that industry healthy and competitive, especially in a time when AMD weren't able to do that. Right. So even though people congratulate AMD for long-term socket support with AM3 and AM4, and we'll see what happens with AM5, there are downsides to that, and some of it is industry-based, especially if people are, for the most part, buying a new motherboard and chip when they upgrade every 3 or 4 years. I mean, not anymore because of the memory pricing. The thing with Diamond Rapids being cut in that way, yes, it does mean that the OEM's product cycle has to change. Instead of Dell launching a new type of server every 12 months, it's now going to be 18 or 24, and they're going to be a little bit annoyed with that. One might argue, well, AMD can pick up the slack. AMD is now 40% market share by revenue, but only 27% market share by unit sales. And that's because AMD's chips actually sell on average for a higher price. That's also because AMD doesn't really target super low core count enterprise and server. Intel still does because that's a market that's worth it to them. So yes, it will affect those OEM relationships, but the idea is that even if that happens, most of the OEMs are in a position where that's okay. But if it brings back a stronger Intel, longer term, the markets will look at what's happening next week, not what's happening next year. So good luck with that. So if you ever want to see the market on a roller coaster, go look at Supermicro's share price.
That's but so okay, I guess sort of slight, I don't know if we covered this, I don't think we did, but slight transition to kind of another Intel topic. But there were rumors a few weeks ago, or maybe a month or so ago, about SambaNova.
Yes, okay. Do you want to explain the story?
So I forget exactly who, I think it was Bloomberg, broke the story that SambaNova was looking for a buyout and looking for somebody to essentially purchase them. I think this was a couple months ago. And then like a month or so ago, they broke again that it was actually Intel that was looking into buying SambaNova. Now,
can I do a full context here for a second?
Yes.
So SambaNova is an AI chip startup. They've raised $1.1 billion, but their last raise was in mid-22. So they haven't raised in a few years. Their product is a CGRA, coarse-grained reconfigurable array. They're the only company to have made it work at data center chip scale. They've had 4 generations of chips, SN10 to the SN40. 10, 20, 30 were all the same architecture. SN40 is a new architecture, but still a CGRA. I believe the new one is called Cerulean.
I thought it was Cardinal.
No, Cardinal was the old one.
Oh, okay.
Cardinal was first, then Cerulean came next. And this is a chip that was initially designed for training and inference, but is now mostly used in training. And SambaNova they were one of the companies that never really said anything about their hardware for a long, long time. And to be honest, they still kind of don't. They did appear at Hot Chips to give an architecture deep dive once. But initially, they were selling hardware, and they couldn't really drive enough enough of a customer base for that. So they started selling essentially tokens as a service. They've got the racks, and you just buy time on the rack to get tokens, or you buy tokens from the rack. They also launched this year a managed services business where you can buy the hardware, but they'll manage it for you. And it also comes with additional protections and what have you. They also went through a massive logo redesign. I was actually wearing my SambaNova socks yesterday, the new logo. I'm not a fan of the new logo. A number of people I've spoken to haven't, but apparently it was very well received internally. That says something. A bunch of people that I know from who have worked for SambaNova almost since it began have all left. I know one guy is with another AI startup who's here. Actually, I need to bump into him and see what's going on. And yeah, I've heard rumors over the years of some of so usually when you raise a funding round, say you raise 200 million, but that'd be on a valuation of say 2 billion. Right?
Yes.
Apparently, I heard some of the restricted stock units for SambaNova were trading at value. So like a 1-to-1, which means that there's no value beyond the investment. This was like 12 months ago, probably at this point. But the question has always been, what's the future for SambaNova? And, given that it's been 3 years since the last fundraise, you either think there's going to be a new raise soon, because we've seen Cerebras do a raise recently, and we've seen Grok do a big raise recently. And they're like two of the other top 4 AI players. That maybe SambaNova was going to do a raise. And if you can't do a raise, what's the alternative? You look for an exit. And if you can't raise, that means you can't really IPO. So acquisition is the way out. I'm not too sure I buy the acquisition rumors fully. I mean, don't get me wrong. Every startup is looking for an exit. The question is, do you exit now? Do you exit later? And how much is your company worth at each time? The complexity comes in the fact that the executive chairman of SambaNova is a guy called Lip-Bu Tan,
who just so happens to be the CEO of Intel.
And the CTO of Intel now. Because Sachin left. And so not only is there a horrific conflict of interest because his investment firm, Walden International, is a big investor in SambaNova.
Apparently they own 10%.
It's which in this world is a chunk. 2, Intel is bleeding money right now, and it's not as bad as it was, but it still means that if there's money for investment, it has to come from somewhere. Does Intel need another AI chip company? This is something that I've touched upon over the last year or two because I felt realistically Habana wasn't integrated enough quickly enough. That's why there's software issues. That's why Gaudi 3 has no new supercomputers, and they can't really talk about any big installations of Gaudi 3.
No.
And Jaguar Shores got cancelled, and Falcon Shores got cancelled.
Jaguar Shores is still apparently happening.
Whether that's got anything Gaudi related in it, we don't know.
Yeah.
And so the question is, do they ditch Gaudi and then try a third time with a startup? Which I've said isn't a bad idea, but get yourself on a sure footing first and invest in a company that actually has a ramp. And the question is whether SambaNova actually has a client ramp, or whether Intel would be taking on something that needs a lot more investment to turn around. Like Intel has other things to turn around first. So this is why, if I was somebody who was looking at these rumors, especially an investor or say, I'd be like, none of this makes sense. Aside from the huge conflict, right? And maybe it not be a legal conflict, right?
No, but it's
still
at least.
Maybe it's not even ethics because people know people. For this industry is at times relatively small in certain fields.
You could call it incestuous, yes.
It's one of those things that if things don't line up properly, and we get this sometimes with acquisition rumors. Does it make sense for these two companies to either merge or one to acquire the other? And you look at the overlap of the product line, and you look at what's needed. There's just no synergy there and don't get me wrong, it could be a great acquisition, but I don't think Intel's in the right place.
No.
And if say an Oracle were to pick up SambaNova, I'd be like, yeah, sure.
Yeah. Or SoftBank, because they seemingly want to buy people.
Yeah. Right now, Intel's not in a position to be, and there's no bad products, only bad prices. So how much would the acquisition have to cost to make sense?
Justify it.
And okay, so SambaNova's raised 1.1 billion. I think it's like 1132, if I remember my spreadsheet correctly. If they were like 500 mil, so half of raise, would that be a purchase?
Apparently, we may be having stream bandwidth issues.
Oh, let me have a check. But yeah, what are your thoughts?
So I agree that SambaNova doesn't really have. I don't see Intel buying them as a good move for Intel at the moment. I agree that they're not in a place to buy SambaNova. If this was Intel circa 2015, completely different story.
Yeah, because they would have just...
They were flushing cash. They had everyone, and they were very much on the top of the world at the time. But 2025 Intel's a very different Intel.
Also, I mean, you could say, well, look at Ampere being acquired, right? That was a very unique situation. For that multiple, I think people weren't expecting that multiple.
Yeah, no.
So you can't just look at that and say, well, ride the wave. That kind of really doesn't make sense. So this is why, anybody who just dives beyond the surf, beyond the headline, can show this doesn't make sense. And this is the difference between a Reuters reporter and a Reuters analyst, right? The report would just say people are talking about.
Yes.
If SambaNova's right for acquisition, then but in speaking with the people at SambaNova, they're just continually going on. I got a press release this week, this new software platform, or the updated software platform. Yeah. So it's stuff is going on. They're not at the show, I believe. So we might see them at CES. We might see them at Chiplet Summit.
Oh, when Chiplet Summit?
And I think this year is actually like second week of February. Chiplet Summit as a conference has always felt weird to me because it's very much a very page play.
Okay.
But like the AI infrastructure summit, that's also very highly page play. So yeah.
Apparently, it's still bandwidth issues.
Oh, yeah. No, my side says it's fine. I've got stream quality excellent. We are only streaming in 720p because we only have a USB 2 cable.
Yeah.
But that's my fault.
Yeah.
It's
Yes, we are. Oh, it's better now? Okay. Weird internet pixies deciding to
it's
take a break.
Well, no, it's what's happened is it's just gone 1040. I think everybody's just kicked out of the keynote. The building has great internet, but when you put 10,000 people running, checking their emails all at once, that's probably what's happened. I know last year in the press room we were able to connect in through Ethernet, but I don't think the interview room does. We were actually discussing with the media person. We're still in an era where event organizers think interview room means I listen to you and do an audio recording and then write it a transcription, not a video recording. Or because we were in this room yesterday for the press briefing, and there was a great wall of logo that I wanted to use for this because that's when we were organizing it, but it's been torn down already, and we don't know why. So yeah, you get what you can get. It's better this than a hotel room, I think.
Yes. So Jay, their first donation. Thank you, Jay. Good morning from George's backup cameraman. So a little bit of a story. Jay and I went to the TACAM booth.
Last year?
No, last night. And I went up and I asked, so...
Did you get your book?
They didn't have the book.
Oh, I didn't have the book of dreams.
They didn't have the book. So I went up and I may have been a little bit confrontational. A little.
Like me with Microsoft last night.
Yeah. I don't know, I was there. But I basically said, hey, you're announcing this new thing. When are you going to have silicon?
Yeah.
And they said, H127, we will be shipping. Okay, cool. Why should I believe that claim since you've told me that for 3 years in a row running? And he's like, oh, we had to do a new process note. Jared asks a fairly easy ball question. So why did you switch notes? To which the answer is to be more competitive with the market, et cetera, et cetera.
That's a fine answer.
Right? And Jared was recording, and the person at the booth was like, sorry, I don't want to be recorded. I'm like, okay, one, you're here. You're at Supercomputing. Two, in the media disclosure, it says we're able to film on the floor at our discretion. Yeah. And three, this is a one-party consent state. And you're out in the open.
That third one was a little bit too much.
It may have been, but...
You were technically in a private building.
But it is a public venue.
Yeah. So we've got like 10 minutes left.
Okay. Well, yeah, and I have to run to go. What's funny is I specifically wore these socks. Nice. So
come on.
Yep. Lisa will appreciate those.
Cornella's
socks. I will be interviewing Lisa Spellman in about 15 minutes.
Are you recording that interview?
Yes.
Okay, cool.
We'll do a video recording.
Yeah.
I'm probably going to pull Andy with me as the camera person and help with setup and all that.
Yeah. You got any other interesting meetings?
I have NEC tomorrow morning.
Cool.
And then I have VAST and Upscale. Oh, and D-Matrix today.
Is VAST with Nicole?
No. I think it was Nicole that told them to reach out to me.
Okay.
But I don't know if Nicole is here or
it's I've got I'm speaking with the next Silicon chief architect.
Okay.
We met the chief architect of Arbel last night.
Oh, did you?
Yep. Yeah. And I think I've got a meeting with Brrrr and then maybe a couple of other things. It's and also because the show floor is so spread out this year.
Yes.
I need to go into Hall 6, which is in the stadium.
Yes, we have essentially overflowed the convention floor, and I think we're using 30 to 40% of the stadium.
Yeah, it's this event is not coming back to St. Louis because there's not enough space.
We're actually starting to be fairly limited in the amount of cities that we can go to. Next year,
really.
For events floor space.
Not really. San Jose Convention Center.
Too small.
Then anywhere in Vegas.
Too expensive. Reno would be first.
Or Taiwan.
It would never be in Taiwan.
But just for clarity, when we said there were no new Chinese supercomputers on the top 500, there were Taiwanese.
Yes, there were Taiwanese supercomputers, but there were no mainland China supercomputers.
So nobody from NASA is here because nobody got approval after the US shutdown in time to make it.
So that is incorrect. There are people from NASA here, but nobody from NASA as an official spokesperson is here.
Right. Yeah. Sorry, we're filming. Sorry, we're filming. We're live. We're live. We've booked the room. The media room's next door. Yes.
Yes.
Yeah. Okay.
Okay.
Or with that, we should probably wrap anyway.
Yeah.
It's
What's funny is they haven't announced where SC-27 will be, but SC-20 is apparently going to be in Atlanta.
no Chicago.
No, Atlanta for 28.
Oh, the 20. Sorry, next year is
Chicago.
Chicago.
We don't know where 27 is, but we do know that 28 is in Atlanta because IEEE already said it.
Okay.
Yeah.
Okay. Yeah.
Suspicions are likely Denver, but not confirmed.
Yeah. Denver's big enough, isn't it?
Yes, Denver is big enough.
Yeah.
Okay.
Yeah. All right.
Yep.
So yeah, it's been we've got some more stuff to talk about next week when some embargoes lift.
Mhm.
Is your article ready?
Mhm.
Yeah. Okay. So stay tuned to chipsandcheese.com. I still need to record something. So yeah. But we've got plenty of content coming out this week and next. So stay tuned for that. Say goodbye, George.
Have a good one, folks.
If you like this content, there are multiple ways to support the channel. You can like and subscribe this video, and many thanks for doing so. There's also Patreon, which gives you access to our Discord. There's a merchandise store and a newsletter, links in the description. For all of you who do contribute, thank you. You are keeping me well fed.